based on these two pages that you've already taken a look at, we're going to focus in on how to draw an atom. And in order to do that, we need two really important pieces of information right here. These two numbers will help us draw an atom. So we're going to start off by looking at the periodic table. You can find a periodic table anywhere. They're all over the internet, all sorts of web pages, that type of thing. Not just anywhere, but. So today we'll look at sodium. There it is. And it has an atomic number of 11 and a mass number of 22.99. Now I've taken that information and I've made a note of it right here. Okay. Now, what I need to be able to do is take that information and translate it over into a standard way of writing this so that no matter where you are on the planet, if you write the numbers exactly like this, the mass number up top and the atomic number down below, everyone will basically understand what you're talking about. So this is a standard, common way of noting something, of writing something down, standard atomic notation. So there it is. The mass number is always the bigger number of the two. It's because it consists of two subatomic particles added together. I mean, we have protons and the neutrons added together. So obviously, when you add a bunch of things together, you'll have a large number. Down below is the little atomic number. And in this case, it's 11, and it only tells us the number of protons. Protons are like the blueprint, the fingerprint, the identity of an atom, of an element. So sodium, no matter what, will always have 11 protons. Okay, so we're going to take that information and use it to draw a Bohr Rutherford diagram of an atom. Okay, Niels Bohr and Ernest Rutherford are the two scientists that came up with this. Maybe someday your name will be used. You'll be a scientist and you'll have something named after you. So let's start off with sodium. So I'm going to just make a little inventory list for myself. Okay, how many protons? That's a lower p and a plus sign just to tell me protons. So we have 11 protons for sodium. Now, if there's 11 positive protons and it's a neutral atom, it must have the same number of electrons, 11 negative electrons. And in order to find out the neutrons, we just subtract 11 from 23. And that tells us that there's 12 neutrons. So now I have all of the information I need to draw my atom of sodium. So the first thing I'll do is I'll draw this nucleus, a circle right here. And inside the nucleus, you should know that's where we find the protons. And in this case, we have 11 protons and we have 12 neutrons. Those are the subatomic particles found in the nucleus. So now we need to draw energy levels, where the electrons hang out, where they are found roughly. So we'll draw this first energy level. It will hold up to 2 electrons if we need it to. And you have to fill up an energy level first before you can draw another one. So in this case, there, our first energy level is full. It will hold 2 electrons. But remember, we have a total of 11, so we have to find a home for 9 more electrons. So that means I need to draw another energy level. This energy level will hold up to 8 electrons if we need it to. So I think we'll end up filling it up, won't we? So we'll go around like this. I find it convenient to place the electrons at these 15-minute marks or quarter marks. And once you've placed them there, you can start to pair them up after that. So now I have a total of 10 electrons in this diagram, but I actually have 11. So I need to draw one more energy level. Now that all the other energy levels are full, I can move on and draw another energy level. And I'll place that one electron that I have left over out there. And that gives me a total of 11 electrons. So that is a Bohr Rutherford diagram of sodium. That's one atom of sodium.